Hey class, Mr. Hanji here. For today's lesson, we are going to be taking a look at section 2.2, which is going to deal with reflections. Now, a reflection is something that you may know from everyday life or previous math class. And really what a reflection is we're just going to flip an image over a certain line or over a certain axis. So we'll talk about what each of those are going to mean and how that's going to look for today. So this is the second section of Module 2. So 2.1, we talked about translations. Today we're going to take a look at reflections, so our second transformation. And much like a translation, a reflection is a rigid motion. So keep that in mind for future reference. All right, so for today we have one learning goal, which states you will be able to draw the reflection of a shape in the coordinate plane. So just like yesterday where we talked about how you go through and draw a translation in the coordinate plane along a vector, we're going to talk about how you reflect something in the coordinate plane. So for each problem, they're going to give you a shape, most likely a triangle, and then they're going to ask you to go through and reflect it either over a line, the x-axis, y-axis, or whatever it may be. So let's get kind of into some stuff today and practice some reflecting. Now, before we jump into example 1, we have some different terminology we need to talk about. There's a couple of ways we can go through and reflect shapes. Okay, eventually we are going to get to, on the final example, talk about how you reflect something using coordinate notation. Okay. The other way we can do that is we use perpendicular lines and bisectors to go through and do that. I'm going to show you a shortcut, though, to do that for today. So perpendicular lines are lines that intersect at a right angle. So lines L and M are perpendicular because they cross at a right angle or 90 degrees. So these two lines are perpendicular. It forms a 90-degree angle, as indicated by the right angle mark. Now, perpendicular bisector of a line segment means that the line is perpendicular, so N is the perpendicular bisector, so it crosses at 90 degrees. That's the perpendicular part. And the bisector part means that this segment is equal to this one, so this line cuts the segment in half, meaning the distance from A to the intersection point is the same distance from the intersection to B. Now, technical way you would go through and do this is you're going to use perpendicular bisectors with the line they give you. So I'm going to show you what that briefly looks like with one point, and then I'm going to go through and show you a cool trick to be able to do reflections a bit easier. So with that said, let's take a look at example 1. Alright, example 1 is going to ask us to draw the image of triangle ABC after reflection across the line L. So for each problem, they're going to give you a triangle, and then they're going to give you a line, which they want you to reflect this over here, somewhere across that line. So we'll talk about how we do that. Now, for example 1a, they've kind of already gone through and reflected the point A to A prime. And what they've done is they've used perpendicular bisectors. So you have to go through and draw a line that's perpendicular to this line that goes through this point. And then you have to figure out the distance from A to this point and then replicate that from here to here. Now, there's a variety of different ways we can do this. You do have to be very careful and very well on point with that. I'm not going to be necessarily worried about you doing it with perpendicular bisectors. Okay, most of the time you're going to be asked to identify where the reflection should end up at. Okay, and you should have a pretty good idea by looking at it. Example 2, we're going to talk about using coordinate notation. Now, before we do that, I do want to practice reflections like this, but I'm not going to use the perpendicular bisector method. In fact, I'm going to use a shortcut trick that's going to use either wax paper or parchment paper. So if in your house, in your kitchen, if you have wax paper or parchment paper, you can always tear off a section of that and kind of cut it up into little squares. And we're going to use that to make our reflections for today. If we were in class, I would give you little square sheets of patty paper that they use for hamburger. I don't have patty paper with me, so I am going to use parchment paper. Either wax paper or parchment paper works for this. Wax paper, you have to press a little bit harder with your pencil to do this, for how I'm going to show you. And it shows up a little more faint, but it does work. Now, if you do not have either of those at your disposal and you do want to try this at home, you could use a piece of paper and kind of hold it down, make sure you have your light on wherever you are, so that way you can kind of see it through. For example, if I move this paper up, it's a little hard to see, but you can kind of see the triangle through there, and you can run kind of through the same idea that I'm going to do with parchment paper. Alright, so with that said, if you're going to do what I'm going to do on paper, you need to use a pencil. If you're just wanting to check on your computer, you can use a pen or felt tip marker. I probably suggest a marker if you're doing it off your computer screen, but don't press too hard. Alright, so what we're going to do is I'm going to take my piece of parchment paper and we're going to lie it on our drawing for this. And what we're going to do is we're going to go through and trace the triangle. Okay, so I'm going to go through and trace my triangle ABC. If you're doing this on paper, be sure to kind of go through and press hard enough and go back and forth on it, over it a couple times. We're wanting to leave a nice set of pencil on that, and you'll see why, because I'm going to transpose it. So I now have my triangle. Kind of go through and mark where A is, so you at least know where a point is going to end up. And then you need to trace the line that they want you to reflect over. Okay, if I trace the line that I reflect over, just like I did there, it doesn't have to be, really pressed in. That's going to give us kind of our starting point. So I am going to reflect over this line, which means I'm going to take my parchment paper, I'm going to flip it over, and then what I want to do is line up the lines so they match kind of on top of each other. And you want to do the whole line so that way you can match up the end with the other end. And then I have my triangle right there, okay, and that's what it's going to look like reflected. Okay, so that is the reflection of this triangle. So this is my pre-image, my triangle ABC. This is my image, triangle A prime, B prime, C prime. Now, if we were doing this on paper, and if you want to go through and try to plot those points or actually draw your triangle, you could go through and kind of lift your parchment or patty paper or wax paper and keep trying to plot the points. Or a fun way to do it is you're just going to draw over top of that triangle on the other side. And what we're going to do, if you drew or pressed hard enough on the other side and you press hard enough on this side, you're going to leave a triangle residue on the other side like that. So that is how you can go through and reflect over a line using parchment paper, wax paper, or patty paper, or even paper, if you've gone through and done that. And then all I'm really going to kind of tell you to do is you just kind of fill it in a little bit more, so that way you have a better reference point. So this is my A prime, this is my B prime, and then C prime. So that's a quicker and easier way than going through and finding the perpendicular point, figuring out how far it is, and then applying that distance to there. So that is a fun, quick way to go through and reflect images using patty paper. And we'll kind of use patty paper, wax paper, or parchment paper, or paper to do that with rotations in 2-3, but a bit different. So I want to go through and practice one more, again, to kind of show you what you need to do. If you have a clean sheet of parchment paper, wax paper, paper, whatever it is, go ahead and pull that out. So for part B, again, we're going to lie that down. And what you need to do is go through and trace triangle ABC. Again, you want to push down hard enough and go over it a couple times to leave a nice part that you can leave a residue. So we're going to go through and do that. Again, indicate your point A. And then once you've done that, you want to trace the whole line that they want you to reflect over. If you only trace over part of the line, when you go to reflect, okay, you have to place it back on the exact point. So if I have the whole line, I don't have to worry about finding that small section of the line again. So again, we're going to take our parchment paper or wax paper, flip it over, and we need to line up the lines again. So like that, make sure the ends match as well. And then we're just going to trace back over our triangle to leave that pencil residue. And we end up with our triangle right there. Now, it's not going to be necessarily an exact or precise spot. It's pretty gosh darn close. This point is just going to be there more so. But it gets the idea across of how I go through and reflect these. Okay, because it goes through and flips them across that line. Again, our A prime, B prime, C prime. So again, that is how you go through and do reflection using wax paper, parchment paper, or paper over a line. So fun way to do that. I know I'm probably geeking out on it, but it is kind of fun to be able to use different resources like that to do a reflection. In this way, you don't have to do the arduous task of perpendicular bisectors. All right, so with that said, that is example one. Parts C and D would have you do the same thing. For our purposes, instead of just pulling out more wax paper or parchment paper and doing two more, I'll leave those for you to do if you would like. If you want to see what they end up looking like, by all means, just take a look at my completed notes. Again, if you are doing this on a computer screen and you're wanting to match or try to see what it looks like, please be careful. Either draw a sketch on paper and kind of, it doesn't have to be exact, but draw a rough sketch of what it would look like on paper, and then use your wax paper or parchment paper and do that. Or if you're doing it on a computer screen, please be very careful to not mark your screen or damage it. I don't really recommend that you actually put the piece of paper up on your computer screen. I recommend you put it on paper and then test it out. But most of the time you should be able to see what it looks like. All right, example 2. So we're going to continue with reflections, but now we are moving into reflections in the coordinate plane. Now, this is the point where I want you to know that this table is going to be super helpful for you. Okay, I'm not going to necessarily sit here and ask you to memorize these right here, right now, because they can be a bit confusing. I want you to know how to use these coordinate notation rules than necessarily worrying about memorizing them for right now. Now, when we talked about translations, okay, translations were pretty straightforward, that if you added or subtracted a number to x or y, it moved it right or left. And then if you did that to y, it moved it up or down. Okay, reflections, as you can see, it either does one of two things. You either add a negative to one of the signs, or we're going to flip x and y, or flip x and y and add a negative. So know that this is a really helpful table to have. I would either suggest you write it on paper to have next to you, or you just have this up on your screen so that you can look at it from the completed notes. So reflection across the x-axis is x comma y goes to x comma negative y. That means you just change all the signs on y. X stays the same for the y values. Positive becomes negative, negative becomes positive. Across the y-axis, you just change the sign on the x values, y stays the same. Reflection across the line y equals x. All you're going to do is take x comma y, and you're going to change it to y comma x. That means you take these points and you just flip them. So if it's 1 comma 2, it becomes 2 comma 1. And then a reflection across the line y equals negative x. You're going to flip x and y, and then you're going to attach negative signs to them. So that's a couple different ways in which we're going to do reflections. So we're going to do reflections across the x-axis, the y-axis, the line y equals x, and then the line y equals negative x. Okay, so each problem will give you a set of points or an image in the coordinate plane, and then they're going to ask you to reflect over a particular line. So we're going to go through and practice these. Again, the rules for reflections is very helpful to have up. We are not going to need or use our parchment paper, patty paper, or wax paper for this. We're just going to use the coordinate notation. This is the most common way that you're going to be asked to do reflections, is using the coordinate rule. Okay? You're not going to really have to be asked to do much on reflecting by using patty paper, parchment, or wax paper. So example 2 is going to ask us to reflect the figure with the given vertices across the given line. So if we look at A, so we have the points M is at 1 comma 2, N is at 1 comma 4, P is at 3 comma 3, and they want me to reflect over the line of the y-axis. So quick bit of memory for you. Y-axis is going to be this axis right here. So what we're going to go through and do is we're going to reflect these points across the y-axis. So first step is plotting your original points. So M is at 1 comma 2. N is going to be at 1 comma 4. And P is going to be at 3 comma 3. Alright, so if we want to go through and reflect across the y-axis, okay, my coordinate rule for across the y-axis is x comma y goes to negative x comma y. So that's going to be the rule that I use, is negative x comma y. So we're going to go through and transform all of my points. So M prime, N prime, and P prime. So all we're going to do for these, because it's negative x, is we're going to change all the values for x from positive to negative or negative to positive, and the y values stay the same. So if we look at M, I have 1 comma 2. That means I need to make this positive 1, a negative 1, and 2 stays the same. For N, I need to make the positive 1 a negative 1, and 4 stays the same. And then for P, positive 3 becomes negative 3, and then 3 stays the same. So I now have my points, so we're going to go through and plot those. So M prime is at negative 1, 2. N prime is at negative 1, 4. And then P prime is going to be at negative 3, 3. So we're going to go back 3, up 3. So we're going to go through and connect our dots for both of these triangles. So that is my image, my reflected triangle. And then this is going to be my pre-image or the original triangle. So we've now taken this purple triangle, we've reflected it over the y-axis to my image, my red triangle, for triangle M prime, N prime, P prime. And that is how you go through and do a reflection across the y-axis. Alright, so you would kind of run through that for parts B, C, and D. Because that feels a bit redundant, I'm not going to go through and do that for every one. Just for matter of purposes, so we can see our rules here while we'll do this, I'm going to take a look at B, and then I'm going to leave parts C and D for you to run through on your own. You can always take a look at my completed notes for some guidance. Alright, so for part B, so we have the points D, 2, 0, E, 2, 2, F is 5, 2, and G is going to be 5, 1. So if I go through and plot all these points, so 2, 0 is D, and then 2, 2 is E, F is going to be at 5, 2, and G is going to be at 5, 1. So if I go through and draw, we're going to end up with a trapezoid as my shape. Now, it wants us to reflect this across the line y equals x. Well, the line y equals x, it goes from x, y to y, x. So y, x is going to be my transformation. Now, just for matter of purposes, to show you what the line y equals x is going to be, just to give you guys a reference. Okay, the line y equals x looks like that. Okay, y equals negative x goes this direction. Okay, so y equals negative x goes that way. Y equals x goes that way. Alright, so I need to go through and reflect these points across the line y equals x using the coordinate rule of x, y goes to y, x. So all this means is I just take all of my points, D, E, F, and G, and when I go through and transform them to D prime, E prime, F prime, G prime, I just take the points I'm given and I flip them. So 2, 0 goes to 0, 2, 2, 2 changes to 2, 2, 5, 2 changes to 2, 5, and then 5, 1 changes to 1, 5. So if I go through and plot all my points, D prime is at 0, 2, E prime is at 2, 2, so it's actually at the same point as E. F prime is at 2, 5, and then G prime is at 1, 5. So I go through and connect my points, and then I have my reflected trapezoid. So this trapezoid is now reflected over the line y equals x to that point. This is my pre-image, my image. You could check with your patty paper, parchment, or wax paper if you'd like, but trust your process. This looks like a reflection. Know that, again, something we've talked about before, these are rigid motions because the reflections didn't change the shape. It may change the position or the orientation of it, but it doesn't change the shape or size. Alright, so that is how you go through and reflect over the y-axis and then y equals x. C is going to ask you for the x-axis, and D is y equals negative x. Again, I'll leave those for you to practice or take a look at my completed notes. For the x-axis, you're just going to change all the signs on the y values. For y equals negative x, you flip x and y, and you change their signs. So, with that said, that is our lesson for today on section 2.2 on reflections. If you have any questions, again, don't hesitate to ask next time you see me, and I'll be more than happy to help however I can. Don't feel bad if you aren't able to use patty paper, parchment paper, wax paper, or paper. Just kind of use the idea of what the reflection should look like now that you've seen a few examples to help you on your homework for today. So with that said, That is it for today. Thank you for listening, and I will talk to you guys later. All right, bye.